Hey guys, today I will show you how to simplify rational expressions with fractional exponents, something like this. Well, there are multiple rules or power rules or exponent rules that everyone should keep in mind when you deal with exponents, when you deal with powers. Everything revolves around these rules, and over here I have listed the most important rules that you should know. So first of all, it's a multiplication rule, and all it says when you have powers or indices with the same base a, and all you need to do, you keep the same base, the common base a, and you just add up the powers n plus m. Similarly, when you divide, sometimes it's called a division rule, when you divide one power by another power with the same base, so provided the same base, this is my disclaimer, so you always want to keep the same base and you just subtract off, you take away the powers. Finally, sometimes it's called a factor rule, when you have two factors a and b and you want to raise it to the same power. So basically all it does, it raises each factor to this power n, and these powers have to be multiplied together. And finally, power and power rule, very important as well, it comes out a lot when you do this exponent. So if you have one thing raised to one power, let's say n, and you want to raise it to another power, let's call it m, all you do again, you keep this base number, or it could be any variable, any letter, whatever you are given, whatever you have, a, let's say, and all you do is just multiply through these powers. In my previous videos, I already mentioned all of these rules, and it's kind of must-haves, and I will mention them while solving these kind of problems. Let's take a look at the first one. Looks spooky, looks bulky, and it needs to be simplified. First of all, let's simplify within top and within bottom separately, since you have something raised to a power, and this something you have product of three factors. You have number and you have another two terms, x to the power, y to the power, and you have this negative quarter, a negative quarter. This is your kind of outside power. I'm going to take each of these terms and I'm going to raise them separately to this power. A big caution, a big warning. Many people forget to raise this 2 to this power. It's vitally important. They just write 2, which is completely wrong. So you have to take this 2 and raise it to this negative a quarter of whatever power you are given. So the same goes for the second term, the same goes for the third term. The same thing I'm going to do simultaneously at one go with my numerator. Lord. Simultaneously at one go, I'm going to do the same thing with my denominator, with my bottom. So I'm going to raise a to this negative a half. I'm going to raise this x to the negative 1 also to the negative a half power, and I'm going to raise this y squared to this negative a half power. So go ahead and let's do it. So your top becomes, so 2 has to be raised to this negative a quarter power, gets multiplied, x squared raised to this negative a quarter, and finally y to the negative 1 also has to be raised to the negative a quarter power. That's my top. The same thing goes for bottom. I'm going to raise first of all your constant or coefficient, if you will, which is 8 in this problem, to this negative a half. So this is again my entire power. X to the negative 1 also gets raised to this negative a half, and finally y squared also raised to a negative a half power. Looks spooky, looks bulky, anyway, keep simplifying. Now, First of all, look at, so you have two powers, and basically for this top and for the bottom I could apply this power on power rule that I mentioned before. So since you have one power raised to another power, all you do is just multiply these powers through. So at this point I'm going to keep this 2 to the negative a quarter as is for now. Now I'm going to multiply this 2 by this negative a quarter, and also your y negative 1 gets multiplied by negative a quarter. Now look at this 8 and look at this 2. You have only these two numbers, and you might notice that 8 is a power of 2, is 2 cubed. And basically I want to express this 8 and rewrite it as a 2 cubed. Why? Because I have 2 to the power on top, and if I had a 2 to any power, another power on bottom, I could divide them by using this division rule. So my aim is to fit it, kind of fit it into these certain rules, certain power rules. So I'm going to rewrite this 8 as a 2 cubed, since again 2 cubed gives me this 8, and it's raised also in this negative a half. So again, by using this power on power rule, these powers get multiplied. So these 3 gonna be multiplied by negative a half. So I'm going to do it. Also, in the same vein, I'm applying this power on power rule for the rest two terms. So it becomes negative 1 times negative a half. And finally for y term, so we had squared gets multiplied by a half. Well, at this point, again, you could do these things in your head, more power to you, it's perfectly fine. I just wanted to spell everything out, and that's my point actually. Keep simplifying. Well, all you do is just simplify these powers. So you have 2 to the negative a quarter on top. Now for x, 2 gets multiplied by negative f1 over 4. So you pull this negative in front, so it becomes overall negative, and you would be left with a half power, so negative a half. And finally for y, you would have just a quarter, since negative 1 times negative a quarter gives you just positive a quarter. Now let's deal with the bottom. So your bottom becomes 2 negative, let's pull it out front, 3 over 2. This is power for your 2 on bottom. X, negative 1 times negative a half gives you just positive a half. And finally for y, you would be left with negative 1, since 2 times negative 1 over 2 gives you just negative 1. Now keep simplifying. Now you have your 2 to the power, x to the power, and y to the power on top. You have the same basis on bottom raised to another powers. All I'm going to do is just I'm going to use this, the second property, this division rule or division property if you will. So I'm going to divide them, and all I do is just keep this common base, and I'm going to subtract off these powers, so for each base individually. So I'm going to keep this 2 and this a quarter minus 3 over 2, so it becomes positive 3 over 2. For x, I would have negative a half minus a half. And finally for y term, you have a quarter on top, subtract off, take away, minus 1, so it becomes positive 1. And all you do is just clean up at this point, at this stage, so these kind of fractions come up, so you could do it basically off to the side. So you have negative a quarter plus 3/2, so you could get the common denominator, which is basically 4. And it's the same thing as negative 1/4 plus 6/4. So the second fraction gets multiplied by 2. So you would be left, so it's the same thing as a 6/4 minus 1/4. So 6 minus 1 gives you 5. So you are left with 5/4. So this is your power for 2. 5/4. So for x, you are going to get negative a half minus negative a half, so it's negative 1. And for y, so a quarter plus 1, so 1 can be thought of as a 4/4. So 4/4 plus 1/4, that would leave you 5/4. So that's power for y term. And that's gonna be your answer for that rational expression with this negative power. Alright, say you have been given something like this. First of all, look at the parentheses on top of your fraction. So you have q and you have q raised to the third power. So basically this first q has this invisible understood exponent of power of 1. So you could always think of this as a power of 1. And first thing to do, I would just collect this q and I would apply this multiplication rule. So I'm going to combine these q terms. So by multiplying them, and all that does is just keep this q, and all you need to do is just add this power. So 1 plus 3 gives you 4. So I'm going to rewrite it. I'm going to keep this 5. First of all, let's write p first to the second power. So p to the second power remains the same at this point. So q becomes again to the fourth power, since 1 plus 3 gives you 4. And I still have this a third outside power. And look at your bottom. So again, 25 is a perfect square number, and 25 is a 5 squared. So I'm going ahead and I'm going to rewrite this 25 as a 5 squared. Why? Because I have 1 5 on top. And I'm going after use the division rule. Similarly, likewise, what I did before. I'm going to divide after. So I'm going to rewrite 25 as a 5 squared, and pq squared remains the same, since at this point I cannot simplify, I cannot combine. And I have still this negative a third outside. Now, so I have 3 terms including this constant, and do not forget this constant, this number or coefficient if you will, also has to be raised to this power. So it becomes 5 raised to, so again I'm going to kind of highlight it, everything has to be raised to this power outside, so including this constant, including this coefficient. So it becomes 5 raised to a third p, and at this point I'm going to multiply these powers through. I'm going to apply simultaneously this power on power rule in order to avoid this bulky notation, this bulky writing, to save time and to save space. So I'm going to just multiply 2 by a third like this, and q 4/3. Also the same goes with the bottom. So 5, 2 gets multiplied by negative a third, so your power becomes negative 2 over 3. So p to the power of negative a third and q to power of negative 2 over 3. Alright, so at this point we can divide, since we have 3 different bases on top, 3 different bases on bottom, and at this point we can use division rule or division property. So all it says, you keep the same base and you want to subtract powers. Go ahead. So a third minus 2 over 3, it becomes positive 2 over 3. So this is your new power for this base 5. Multiplied p, so 2 times 1 over 3, basically it's 2 over 3. Minus, you want to subtract off, take away negative 1 over 3. So it becomes positive 1 over 3 overall. And finally your q term, so you have this power 4 over 3, and again you subtract off, you take away this negative 2 over 3, so it becomes positive 2 over 3. And again these nasty and pesky fractions come up, so we can't help it, just keep going. And all you do is just clean it up. The last step, hopefully. 5, 1 over 3 plus 2 over 3, it becomes 3 over 3, which is basically 1. So the first power, we typically don't write this first power explicitly, so you would be left with just 5. So it comes out to be just 5. P term, 2 over 3 plus 1 over 3, the same power. It turns out to be just 3 over 3, which is 1. Perfect, fine, keep going. So it's invisible 1, it's understood to be 1. Moving on to the next term, which is q. So 4 over 3 plus 2 over 3. You have the same denominator, keep it, and all you do is just combine, just add up the numerator. So 4 plus 2 gives you 6, 6 over 3 gives you 2. So you are left with the second power for your q. So 5pq squared, that's gonna be your final answer for that one. Well, it's a little bit tedious, especially when it comes to fractions, something like this, but hopefully you've got this grasp, you've got this pattern. So just nothing special, it's kind of mechanical, technical process. Just apply these rules as long as you can apply them, and do it with exceeding care, since you don't want to miss something like you do not raise a number to the power, or you slip up when you do these fractions, when you do this math with fractions. So just keep watching these signs, especially when you divide, and these negatives when you divide. So positive, negative also might trip you up. So just be very, very careful. Alright, with this being said, I hope it has been helpful to you. Many thanks for watching, and by the way, I have other videos on powers and radicals, and the links would be down below in the description box. Also, you could check out my playlist for these radicals and powers problems. Alright, I know that everyone hates math, but if you like my video, please hit this like, share with your friends, leave the comments down below, and be sure to smash that subscribe button if you haven't, so you will not miss out my new